Today I'll be showing you guys how to fill in the corner pieces here so you no longer have a weird gap, as well as to put a nice border on your roof with a nice roof setting with an actual roof and a railing, and give you the ability to actually change the thickness of the roof to be whatever you want, and to change also the height if you want to have just a really large or really short little border at the edge. Let's get to it. Let's get started with the first thing, which is these corners. Right now, because of how we have the actual geometry and everything set up, we end up with kind of holes here in the corners, and we really don't want these. We want to kind of get rid of them. So what I'm going to do is actually add a pillar, basically, that fills into the corner. Now, for yourself, you can choose one that blends perfectly with everything. I'm going to be using this one right here, which has a pivot in the bottom center, and we're just going to put it right here in the corners to give it a nice little design. And you'll see how the size of this doesn't actually matter. We're going to scale it automatically to the size we need here. So in order to put everything in the corners, we actually need to have some kind of graph that will get us the corners. And by taking the graph that we originally used for the walls, we can modify it and create a new version of it. We can get a graph that gets us just the corners. So in our subgraph, here is my PCG create walls. I'm going to go ahead and duplicate this. And from here, I'm just going to rename it to create corners. Let's open it up and take a look at what we have here. In our actual original wall, we're taking the wall size, we're dividing by 2, we're taking the positive in X and the negative in Y, offsetting the first 2 points, and we're doing the same thing in Y, positive and negative, and we're taking the difference between all of them, merging the points, and that's how we get the walls. We're also adding a little bit of an offset because our walls have a pivot that is kind of in the side and not in the center. So we're going to need to do just a few modifications to this one to get corners instead. I'm going to take all of this and just scooch it over to the right, and basically from each of these transform points, we're going to need another transform points. So I'm going to search for transform points. I'm going to duplicate it 3 more times, and I'm going to hold control to move the points from connecting to the actual first transform points to connecting to the second transform points. And then we'll go ahead and reconnect everything. Now, basically, I need to offset them by the positive X that we had here. We want them all offset that way. So what I'm going to do is scooch this over. I'm going to open it up, and I'm going to drag out of this make vector attribute from our positive X, drag out, plug into offset min and offset max with just a little bit of a reroute node. And I'll add another reroute node and kind of move it up here and close this up. I'm going to do the same thing for all of them. They're all going to have the exact same offsets in the same direction. But this is all relative, so which is why we're doing it 4 times instead of doing it once at the beginning. Because we have rotated each of the points to the actual faces of the box surrounding, effectively, when we offset it, they're all going to be offset kind of like this. One goes this way, one goes this way, right? They're offset relative to themselves. If we did it beforehand, they would all just move over, which we don't want. Once you have this part is done, we can move on to this connection section, which is a little bit different. We're not cutting out the differences the same way, so I can hold Alt and just disconnect these. And now what we want to do is get our new differences. So I'm going to take our first points, and I'm going to merge them using a merge points node with the last ones. And I'm also going to merge the second and third. So the outer 2 are merged and the inner 2 are merged. The inner 2 are going to go to the ones that we didn't put together. So we did 2 and 3, so it's going to go to 1 and 4. And the second one, which we did 1 and 4, is going to go to 2 and 3. We're almost done. We just need a little bit more before this transform point. So I'm going to scooch it all over. I'm going to take these merge points and also scooch them over. And I'm going to take them and duplicate them twice over here. Because now what we want to do is take our differences and combine them. The top 2 and the bottom 2 together. And you want to merge the points. And then we need 2 more difference nodes. So I'm going to take 2 of these difference nodes and duplicate them. I'll go ahead and detach all of this. And the merged points are going to go into the source. The bottom merge points goes to the bottom source. Top merge points into the top source. And as you might have suspected, we're just cutting each other out in a simple cross here. And the output then reconnects back into the merge points here. And the final thing in here, I want to just remove those transform points. We honestly don't need it here. We're going to offset it by a different amount based on what we need, but we're not always going to need it in this particular way for the corners. So I'm going to remove it, plug it in like so, just all the way through, and delete this, which also means we no longer need our wall thickness in general. So I'll go ahead and just remove that point entirely. So now we can go ahead and set up our actual corners and the pillars. So let's go and do that right over here. So for the first thing we're going to need is grab our original spline points, which is just our spline data with the actual size of our walls. We're going to get our original spline points, and we need to copy the points all the way up to the top. So I'm going to get our copy PCG point up simple, and this just copies the points up based on the amount of floors we have. If this is your first video and you're a little lost about the nodes, check out the playlist down in the description below to get caught up on all these wonderful nodes that we have created to make our setup a lot simpler and more modular. And go grab our create corners PCG node and just drag it in and create our subgraph node. I was going to show disable because we don't have things plugged into it just yet. That's okay. And grab our wall size property from above, plug that in, and plug our spline points in like so. And now if I go ahead and sample it, you can see we have corner pieces, but we also have all of this. Now, don't worry about all of this. The reason is this seems to be a bug when sampling the subgraph node itself. If I do a simple transform points, and I don't even need to do anything with this node, and just sample it instead, you will see we only get the corners, which is what we want. So the next thing is to grab our mesh, plug it into our data asset, and actually scale it to fit that location. So let's go ahead and add those to our data asset. To do that, we're going to go into our data assets folder. We basically need to create more data asset variables to account for these corner pillars. So I'm going to open up our PDA modular building. This is where we contain all of our variables here. I'm going to duplicate our floor and just rename this to corner pillar. And that's pretty much all we need to do. I go ahead and compile it. And now if we open up our DA regular building, you'll see we have now a new section corner pillar. I can go add an entry here, open it up and put our pillar in here. I'll search for pillar, plug it in. And right now I only have one variation, so that's perfect. One thing to keep in mind, I just update the PDA file. So I need to go to graph settings and update our data asset because this has been cleared here. So I'll reselect our DA regular building as our default. Now that everything is plugged in here, we can go back over to our PCG building blueprint. And we just need to set up the same thing we did before using our PCG scale wall size, our property, our seed. I can just duplicate all of this right over here, plug it all the way through. Now our get actor property from object path instead of floor is going to be what we called it here, corner pillar. I'll go ahead and just copy paste it in for convenience right into our property name. Now our height is going to be our floor height. So I'm going to duplicate our wall height and plug it into our height. And our depth and width is actually going to be our thickness because effectively we have pushed out the sidewalls by our thickness, which means that area is the thickness. That's what we're going to plug in. I'm going to grab our wall thickness property, duplicate it down here, and plug it in both a width and depth. From here, we can already test the static mesh spawner. So if I grab ourselves a static mesh spawner and in the detail panel, change the selector type from weighted to by attribute and change the attribute name to mesh, you can see we have the actual pillars. They're just not quite at the right location because the point is kind of in the middle there. We want to offset it a bit in both the X and in the Y. So from the static mesh spawner, I'm going to grab ourselves a transform points, drag out an offset min and search for make vector attribute, plug that into both offset max as well. And the detail panel, change for vector 3 to just vector, so you have 3 inputs. From here, we can grab our wall thickness and divide it by 2 because we want to offset it by just half of it. We'll use a create attribute to set the number 2 here for the division. And now we'll go ahead and plug this into the X and into the Y to offset it. And you can see it is there right in the corner. And you can see in every single one of these corners, we have our little point here, which is fantastic. And this method does not put them in here. So now we have every single one of these perfectly aligned. Now there's a slight gap here, and that's to do mostly with the size and shape of these meshes. They are not perfectly flat here on either side. You can see that has a little bit of a variation here. So in a future part, we'll go ahead and add a little bit of a modifier where you can apply on top of these shapes so that fill in areas where maybe you want a little bit of overlap you're fine with, or maybe move them a little bit. We'll take care of that in a future part. For now, our wall corners are all finished here. If you guys are enjoying the tutorial so far, I would love to hit the like button and subscribe if you're new for more awesome tutorials like this. Let's get back to it. Let's go ahead and add in the actual roof. We'll start with just the border around the roof. And in my case, I'll kind of reuse the same mesh as I did in the corners. It'll look nicer together, but we'll add in separate inputs. So if you wanted to, you could have a different piece there. So let's go back to our PDA modular building. I'll duplicate our corner pillar. This is going to be our roof border wall. I'll just rename it as that. Compile it. And now in our DA regular building, I'll add another input for our roof border wall, and I'll plug in the same pillar in my case for both. And as a quick reminder, when you're setting this up and you're swapping meshes around, just make sure they're always in the same relative position for their pivot. So if you had your mesh created where the pivot point is in the bottom center, any mesh that you swap or add to that array, make sure it is also in the bottom center of your mesh. If you created it originally with the offset on the side, make sure it's still on the side for every copy that is that. You want to make sure all your pieces are modular, just a good modeling in general. We can of course add an offset down the line per mesh, and we'll probably take care of that. But for the time being, make sure your pivots are all consistent. And now we have the roof border wall plugged in. We go back to our PCG building and we see we have errors. And the reason is, and again, in our graph settings, our data asset has been cleared. We'll go ahead and reselect it as our default, and now all the errors go away. So we'll get started the same way we always do. We're going to get our original spline points. And to get the borders really simple, we basically are doing the same thing we did before. We're going to create the walls. Duplicate that over here, plug it in. Now this creates the walls for the first floor, but we want it to be for the roof. All we need to do is grab ourselves a transform points node, open it up, plug in our make vector attribute into the offset min and max, and change the output type to vector. And all we need to do is grab our wall height and our floors as our properties, duplicate them over, and just multiply one by the other. This will effectively move our floors all the way up relative to the amount of floors we have. And we just want to plug into Z. If I go ahead and sample this transform points, you can see already we have this nice border placed here. So now let's plug in the mesh and see where we're at. As before, I'm going to grab our scale wall size, our object, and their seed, duplicate that over, plug it in. Now our width is going to be our wall size. Our height is actually up to us, and so is our depth. This is just how thick and deep do we want it. So what we can do is create two new variables for our roof, for our depth and our height. So I'll go ahead and create a new variable in our original blueprint that contains our PCG graph and our spline here. This is going to be our roof border wall thickness. It is going to be a type float, and it's going to be exposed. And I'm going to actually organize this a little bit by putting it into a category called roof. And then I'm going to duplicate it and change it from thickness to height. I'll go ahead and compile it and then change our thickness default to be something like 10. And I'll make the actual minimum value and slider to be 1. And same thing with the height. I never wanted to go below 1, and I'll make the default to be 100. And now I can go ahead and just copy one of these and get ourselves a new get actor property, paste in our property name for thickness, plug that into our depth, and then change the second one for height and plug that into our height. At which point, as before, we grab ourselves a static mesh spawner, change the mesh output type to by attribute, and our attribute name is mesh. And one thing we need to make sure we do is this object from path. Right now, I duplicate it from the floor section, so we don't want to have the floor. We want it to be our roof border wall, so I'll go ahead and copy that and paste that into our property name from our object path. And now if we take a look, we can see, okay, we got our piece. That seems to be all good. And in our roof section, I can go ahead and change the value here. If I make it thinner or thicker, that is excellent, but it is a little bit offset. We need to kind of move them off a little bit. And you can see one other problem we have kind of here is this little gap. This is happening because this is actually on a diagonal. So we're effectively getting this gap because the actual measure bounds are right here. Again, for now, don't worry about it. We'll go ahead and use this for now. And next time we'll show how to set up all of these little variations and modifications for all of these pieces. The main thing we definitely want to do is offset it. So I'm going to grab ourselves a transform point, plug in our make vector 3 attribute vector into offset min and max as always. And what you do is offset it by half of our wall size. Take our wall size, divide by our create attribute at 2, and divide by 2 in X. And you can see now we have our border, but of course we're missing the corner pieces as we have before. So now we can do with the same thing we did in the corner pillars right here, but on a larger, thicker scale relative to the actual border. So we can actually just grab our original spline points and our offset vertically from our roof border wall, duplicate it down here. And this time, instead of creating the walls, we want to create our corners. So I'm going to grab our create corners, I'm going to duplicate it over here and plug this all the way through into our transform points. And now if I sample our transform points, and now with the point sample, you can see we have it right here. It's a little bit low, so we'll probably need to offset it. But let's see what we get. From our roof border wall, we're pretty much going to take this entire thing here. I'm going to duplicate it down and plug it all the way through. I'm also going to grab our static mesh spawner at the end so we can immediately see it. Now, we don't want it to be the full length here. We only want to be the width. So instead of wall size, we're going to actually put in the wall thickness into both the width and the depth. We're going to keep the height the same. So now if we take a look at it, we can see it is kind of not in the right place. Well, actually, the corner piece is in the right place. What's actually not in the right place is this border. And the reason is, if we go ahead and modify our wall thickness, let's say from 100 to 50, you can see that this gets thinner just like the actual corner piece. But if we go very low, you can see there's now this gap. And that's because the pivot point is in the center. So we want to move these walls to align with this. So over here for our roof border wall, we want to offset it in Y. And the offset is basically our original wall thickness. So I'm going to take it, duplicate it over, and then multiply it by -1 using our create attributes set at -1. And that is going to go into our Y. And you see, as soon as I did that, all of this lines up. And now if I change the thickness, so let's say 50 or 100 or 150, it all lines up. Now we do get some overlapping here, depending on the thickness of the mesh that it was designed as. This will happen. So don't go too far unless you're okay with overlapping. But you can see now we have a nice actual border that all connects through. And once we fix this little gap, which we can honestly just hard code for now, which we can do with an extra transform point, so that way it'll be just easier to remove later. I'll go ahead, plug that in right in between here, open it up, and use our create vector attributes in the scale min and max. Now for our X, we're going to just create an attribute and scale it by 1.1. And in Y and Z, we're going to change that to just be a regular one, plug that all the way through. And in our transform points, make sure to uncheck uniform scale. And now you can see we now have the full border. There's technically a little bit of overlapping, but you now pretty much can't tell. So that's fantastic. That is all working. So let's take care of some other stuff, starting with the floor. At one point, we had the floor actually having their own wooden texture, so we could put that back on. The ceiling down below has its own ceiling texture, so we can do the same thing with the floor. So here's our floor ceilings. For our floor, I'll go ahead and open up the template descriptor, and I can override the materials that are there by clicking the plus button and index 0. I can apply my wooden material that I have, and now you can see we have the nice wood. So now let's go ahead and add in the actual roof. And the roof is also going to need the ceiling, just as we had before, because obviously this floor also needs a ceiling. So we can kind of reuse the floor ceiling setup. I'm going to take pretty much everything except the copy points up simple, take all of this, duplicate it over here. And then from our roof border wall, I can copy this transform points up all the way to the roof and place it right here between the original spline points and the wall size. And immediately you can see we have our roof wall and the ceiling. We don't want this actual material for the roof. We want the original roof material. So I'll go into our mesh and go ahead and just remove our override materials here. And you can see we have our nice roof back. And down below, we have our wooden floors and our painted ceilings. Now for the time being, I'm leaving the same meshes for our floors as I do for our roof. In the future, we'll go ahead and rework it and give it actually separate controls for both the actual interior floors and ceilings and a separate one for the actual roof. But you should also have enough right now to go ahead and implement that for your own setup using the data asset stuff I've shown so far. As always, the project files for this are going to be available on my Patreon, where you can join these wonderful people here in supporting what I do. It really means a lot. And if you'd like, come join the community in the Discord that's linked down below. Thank you again to the patrons, and let's get back to it. And now to give it a little bit of decoration, let's go ahead and put a railing just on top here now. And to do that, it's going to be very simple because it's going to be just like we did for the border wall. So here's my roof border wall. But the thing is, I want to change something. I want to place this mesh on the roof. And the only thing that I want to really do is maybe adjust the width of it to actually be the length of each module. Now, I'm aware that scaling this will cause it to stretch. So keep that in mind. If you do it this way, it will cause it to stretch or shrink. So if you're doing cables, just, keep that in mind. But I want the other axes to stay the same. I don't actually want them to be moving. I don't want to modify the height or the thickness, just the length. So let's make a new setup that just does the length. And it's quite simple. For that, we can just go ahead into our scale wall size, open it up, and we can navigate to this location. There's our scale wall size. I'm going to go ahead and duplicate this. I'm going to rename it to scale wall length only. Now, open up the scale wall length only and make sure you have that one, not the original. Next thing you want to do is grab this scale mesh to size. Go ahead and navigate to that, and we'll duplicate this. Instead of to size, I'm going to call it scale mesh length only. So now I can go ahead and take this length only one and drag it in here, or I can just override the graph if it is selected by dragging it on top, and then we can open it up. So for the length only version, we just need to unhook up the Y and Z. So I'll go ahead and delete these, that, and that. We no longer need these inputs, and we no longer need this depth and height. So I'll go ahead and delete the pins from the input. And now we're just left with just the X version of it. And one very important thing not to forget is we are scaling here. So you want to grab out of here, search for create attribute, and you want to plug in one in both into Y and Z. Because unlike the offset, we don't want to scale by 0 in Y and Z because then things will break. And over here, you can see we just have the width now. So again, here I can go ahead and come in and delete index 3 and 4. And now we're left with just what we need. So now we want to grab our new scale wall length only, drag it out, and create a subgraph node. And now going off our roof border wall, we can kind of reuse what we had here. So let's just drag this up, duplicate our data asset up, plug that in, grab our seed and grab our wall size, also duplicate that up, plug all of that in, and plug our transform points from below up top. To make this a little bit cleaner, what I'm going to do is actually just use a named reroute. So I'm going to detach this by holding Alt, drag out of here and search for named reroute declaration node, and then I can hit F2 to rename it, and this is going to be our roof corner points. I can just drag it all the way through to the end, but now here I can also just get our roof corner points and plug this all the way through. So I don't need to actually have this right next to it. If I don't want to, I can just move it kind of a little bit above into their own area. But if I sample it, you can see it is now out here in the edge. So now let's go ahead and add another mesh in our PDA modular building. We're going to duplicate our roof border wall, and this is going to be our roof railing. Compile it. In our DA regular building, I'll add another entry for our roof railing, plug in my railing into the mesh here. And as before, because we have updated the PDA file, go into the graph settings and reselect your default data asset. Then in the roof border wall object path, we don't want a roof border wall. We want roof railing that we just set up. So now if we sample this, you can see we have our railing, which is great, or at least the points for them. But of course, the position's a little bit off. So let's go ahead and add ourselves an extra transform points here. And then we're going to go ahead and spawn the mesh. I'll go ahead and just duplicate the static mesh spawner with the set by attribute here and plug this all the way through. As you can see immediately, it is kind of in the wrong position. We want to push it inwards and possibly a little bit up. So our transform points as before. Grab ourselves a make vector attribute, set it to be vector 3, and plug it into offset min and max. The offset is going to be our roof border wall thickness. We're going to take that and multiply it by -1 in B and plug that into our Y. You can see it is just there right against the edge. We kind of want to push it out even further, or what we can do is put it on top of this as though it's plugged in on top. So if we want to do that, it's quite simple. Instead of multiply by -1, we also just want to divide by half. So I'll just scoosh this over and go divide and add another create attribute by 2 and plug that into a Y instead. And now we want to move it up. And we want to move it up based on our roof border wall height. So we can just duplicate that over and plug that into Z. And immediately you can see right on top of this border, we have our railing just like that. And of course, as before, everything here is going to scale based on the size of the little pieces. If we make it wider or narrower, or if we make it taller or shorter, everything scales accordingly because we have everything kind of dynamically calculated based on the dimensions of the mesh itself. So just like that, we have effectively a complete building. Now it has no entrance yet, and we would like to have some kind of offsets potentially. Maybe we want to scale this one up, fill the gaps here, and we'll go ahead and take care of that next time. Now, I've used a lot of loops in today's tutorial. If loops are a little bit still confusing, check out this video right over here where I go more in depth on specifically loops in PCG.